Вперед!
Good afternoon, everybody. The title of
Да.
our presentation is Advanced Service Data Provisioning in RoF-based mobile backhauls fronthauls. I am Mikhail Belkin, the presenter. My co-authors are Professor Alexander Sigov, the president of our university, and Leonid Zhukov, the research engineer. We are from MIREA, Russian Technological University, Moscow.
Вперед!
Here is the abstract of our presentation. We proposed a new cost-efficient concept to realize a real-time monitoring of quality of service metrics in 5G and beyond access network. For this goal, we use a separate return channel based on a vertically cavity surface emitting laser in the optical injection locked mode that simultaneously operated as an optical transmitter and as a resonant cavity enhanced photodetector. The feasibility and efficiency of the proposed approach are confirmed by a proof of concept experiment with one optical transceiving high-speed digital signal with multiposition quadrature amplitude modulation of a radio frequency carrier. The slide contains the outline of our presentation, including introduction, modern tendency to service provisioning in next generation radio access networks, NG-RAN, the proposed design concept description. Then, to validate the proposed concept, we present the layout of our experimental testbed and the experimental results referred to transmission quality of the information at service channels. The key results of the presentation are discussed in conclusion sections. Finally, the main experiments of the authors in the field are presented. In recent years, with the maturing of 5G and R systems, the design of access network has acquired some significant change. In particular, the centralized radio access network (CRAN) that passed from 4G LTE network was standardized into the next generation RAN, NG-RAN. Following it, some new function block, such as a central unit, a distribution unit, and a radio unit were introduced. The key reason for this transformation was in using in CRAN the common public radio interface with time division multiplexing between baseband unit and remote radio head. This approach led to the data transfer rates up to hundreds of gigabit per second, which makes this interface economically unjustified for 5G and beyond. This slide depicts a typical architecture of NG-RAN where a central unit, distribution unit, and a set of radio units are duplex connected via fiber optics communication lines, while radio units and mobile user terminals intercommunicate wirelessly. Generally, as optical networks evolve to fulfill highly flexible connectivity and dynamicity requirements, it is increasingly important that NG-RAN also provides reliable connectivity and improved network resource efficiency. In addition, collection of different types of data from various sources is necessary for applying automation techniques to network management. Such scalability and flexibility are particularly important for the wide area network, in particular for streaming telemetry. Moreover, an efficient optical performance monitoring design should consider different scenarios, including large-scale disaster, when a prompt reaction is needed but the limited bandwidth is available now. Projecting the above problem for the purpose of this paper, we can conclude that in the newer generation access network, providing the function of the low-cost real-time monitoring and the quality of service metrics, are a matter of great importance from the point of view of their maintenance. In this case, the issue can be solved by additional introducing a special node into the distribution unit, which is responsible for the accumulation and processing of monitoring results. However, a more promising solution from the point of view of reducing the total cost and latency might be the introduction of an additional function from the existing indispensable element of X circuitry, return transmission of the optical signal to the central unit and its processing there. A promising technique for implementing this approach through the simultaneous use on an optically injection load vertical cavity surface emitting laser as a laser source and a resonant cavity enhanced photodetector was proposed for the bidirectional optical communication and recently developed by us referring to microwave photonic circuits. With the development of techniques and technologies of 5G and R networks, it became clear that this is not just a new standard for mobile communications. In general, the widespread introduction of core and access network of the fifth and subsequent generation should lead to a social transformation of the world community, radically changing the principle of communication, architecture, economy, and the level of service of local and global telecom networks. For this purpose, known and newer for cellular communication concept, paradigms, approach, scenarios, technologies, mechanisms, tools, and services are being developed. In particular, they include NG-RANs, radio fiber-based mobile backhaul fronthaul, as well as enhanced mobile broadband, ultra reliable low communications, communication, utilization, and so on. The results of the above innovations should lead to the significant improvements in the quality of service and key parameters of NG-RANs. Thus, the recommendation of 3GPP identified the following outstanding key indicators of new generation networks. Downlink peak data rate up to 20 gigabit per second. Uplink peak data rate up to 10 gigabit per second. The maximum density of the IoT devices connected to the network in the urban territories is 1 million devices per square kilometers. Autonomous operation of the IoT devices without recharging the battery for 10 years. Vehicle mobility at a maximum speed of 500 kilometers per hour. Besides, advanced monitoring framework of optical networks aimed at the continuous remote, automatic and cost-effective supervision of the physical layer has to satisfy the basic set of the requirements. 1. Fast and accurate detection of the performance degradation and service disruptions. 2. Accurate tracking down location of the network failure. 3. Monitoring should be not intrusive and not affecting normal network operation. 4. Compatible with various types of optical networks. Besides, to meet the goal of 5G and beyond network infrastructure should be facilitate a high level of flexibility and automation. In particular, monitoring and that give rise to estimate accurately the quality of service of new light paths, to anticipate capacity degradation or to predict and localize failures, among other, to facilitate this automation. At the same time, network operations and management increasingly relies on the ability to stream and process in the real-time data from network equipment. An integral part of the operation and management is to make sure whether the operation conditions are normal or not, and if need, by quickly recovering and mitigating the problems. The goal to have network management, automation and abstraction of open line systems could be possible by the software-defined network technologies, which requires accurate data from the element of the network. This slide shows the block diagram of the proposed duplex communication channel for NG RAN. The solution is related to the introduction of an additional function to existing indispensable element of its circuitry, namely the simultaneous use of optically injection-locked VCSEL as a laser source and a photodetector. This slide demonstrates testbed for the proof of concept experiment that includes tunable semiconductor laser as a master laser, optical modulator, erbium doped fiber amplifier, optical circulator, optical fiber, photodetector, low noise amplifier, DC source, vector signal generator, and mixed signal oscilloscope. In this slide, we present measurement of small signal gain versus radio frequency characteristics. Left for the information of downlink channel of the distribution unit under test, where OIL-VCSEL operates in a laser mode, and right for the service or uplink channel where OIL-VCSEL operate in a photodetector mode. In this slide, the experimental results for the radio frequency spectra of information channel left and service channel right are presented. When optical carrier of the frequency near 192.2 terahertz is intensity modulated by the radio frequency signal of 5 gigahertz that modulated in the format of 64 quadrature amplitude modulation at the rate of 560 megabit per second. This slide demonstrates the results of measuring quality of transmission. The following outcomes This slide demonstrates the results of measuring quality of transmission in the information and service channel under test, including the constellation diagram left and error vector magnitude values versus optical line length right. The following outcomes can be drawn from the experiment confirmation. In the OIL-VCSEL under test, the introduction of optical injection locking led to the 6-fold expansion of the radio frequency bandwidth for the information channel and to 8-fold for the service channel. In the distribution unit under test, the values of error vector magnitude in back-to-back configuration are 3.2% for the downlink channel to radio unit and 4.3% for the uplink channel to the central unit, which is significantly less compared to the standard error vector magnitude threshold for 64 quadrature amplitude modulation. The maximum acceptable transmission quality is achieved when the distance between central unit and distribution unit is increased up to 5 kilometers, which is realistic for a practical physical. The new cost-efficient concept to realize real-time monitoring of quality of service metrics and other service data in FISG and beyond access networks using a small cell architecture is proposed and discussed. The essence of the proposed solutions is investigated in details on the example of a block diagram of a duplex communication channel, including a microcell base station and a functionally split picocell base station containing a central unit, a distribution unit, and a set of removed radio units, each connected via optical fiber link. A distinctive feature of the proposed approach, which provides an improvement in the power and cost characteristics, is to use in the distribution unit a vertically cavity surface emitting laser in the optical injection locked mode that simultaneously operating as an optical transmitter and as a resonant cavity enhanced photodetector. The feasibility and efficiency of the proposed solution are confirmed by the proof of concept experiment when optically transmitting a high-speed digital signals with 64 position quadrature amplitude modulation of a 5 GHz radio frequency carrier, which is widely exploited in access network of fifth generation cellular communication system based on radio or fiber technology and small cell architecture scenario. The closing slide shows the main parts of the authors in the field of presentation. Thank you very much for your attention.